Hey everybody. I know that this lesson is not easy. It definitely got much more complicated with today's lesson when the numbers started happening kind of on the inside of the function, and now it's kind of has this shift to it. So I'm hoping that me going over a few of these problems here on the homework will help provide a little bit of clarity for you. One of the questions that you guys were asking about was number 4. And so I just want to start real quick at just kind of dissecting a little bit what each of the parts represent. So I made some little notes off the side in purple here. Things were worded a little differently on this particular worksheet. When it says here, flipped over the midline, that's you just saying yes or no to whether it's flipped. Okay, so when you're answering that question, you are looking at the number in front of the trig function, and if that number is a negative number, then you say yes that it's flipped. Otherwise, you're going to say no. So on this one, it's not flipped. The other thing that was just worded slightly different on this worksheet, previously, we had a blank that asked you for the midline, and instead of using the term midline, the blank was asking you for the vertical shift, which we know is always how much you're either adding or subtracting on the outside of the parent function. So vertical shift means the same thing as midline. In this example, the midline would be at -5. Now, hopefully you guys caught that on numbers 1 through 4, you did not need to draw the graph. That's why there was no XY axis. I just wanted you to answer the 5 questions. The first 3 are pretty quick and you can pull them from the equation. The next one is the amplitude. The amplitude is the number in front of the trig function, but if that number happened to be negative, you never write the amplitude as negative, you always write it as positive. So the amplitude is 3.5. It also would have been okay if you wrote it as 7/2 as an improper fraction. Okay, now here's the new part from today's lesson. The word period means how long is your wave? Like how many degrees or how many radians does it take for the wave to start at the beginning and finish through one cycle? Okay, to get the length of your wave, again, that's the period, you have to know where does your wave end and where does the wave begin, and you subtract end minus begins. Okay, so to answer that question, and I also think that these last 2 blanks were on a different, in a different order, maybe on the notes page or in the video. Okay, so make sure they can be in any order here. Just know what each of these things mean. Period is the length of the wave. Okay, so what you're going to do is you're going to grab this part here that's in the parentheses. Okay, and I'm going to write that down first. Now, I immediately notice that I see a pi symbol here. That is telling me that this problem is done in radians, not in degrees. So I'm going to put 0 on the left for 0 radians, but instead of putting 360 degrees on the right, I'm putting 2 pi radians. That's the equivalent of going all the way around the circle in radians. Okay, so you're going to want your calculator handy, okay, because you're going to be using that to help us solve this inequality. But the goal here is to try to get the x that's in the middle of this inequality by itself. Okay, so the first thing you would want to get rid of is the fraction pi divided by 8, and we would subtract that because we can see that, you know, it's added right there. Okay, and so you need to do that subtracting to all 3 sections of the inequality. Okay, obviously that's going to make it cancel from the middle. Now on the left, we have negative pi over 8. In the middle, we only have 1/4 x. And then over here, here's where you're going to use your calculator. Now, do not type the pi button on your calculator. Instead, I want you to only enter in the coefficients. So what you're going to type on the calculator, and I'll draw it up here just to show you, you're going to type 2 for the 2 that's in front of this pi, and then you're going to subtract from that the fraction 1/8, and that's for this fraction here that's in front of that pi. Okay, so on your calculator, type 2 minus 1/8. Okay, now you're going to see a fraction. Or I'm sorry, you're going to see a decimal, like 1.875. Switch that into a fraction. Okay, that's 15/8. And then when you write it down here, reattach the pi symbol back onto the answer. Okay? Okay, now we need to get that x by itself. I encourage you, when fractions are involved like this, it is better, rather than dividing by a fraction, to get rid of the 1/4 by multiplying by the reciprocal. So multiply the middle by 4, then that means you're going to multiply, the ends here by 4, okay? And so if we were to do that, obviously now we have just an x in the middle by itself, okay? And then we're not cross multiplying here. You're going to multiply across the top, across the bottom. That's going to give me -4 divided by 8. Now, if I were to type -4 divided by 8 in on the calculator, switch it back into a fraction, I'm seeing -1/2, and then I reattach the pi symbol. So it's really -pi/2. Okay. Next one, I'm going to multiply the numbers in the top together, but not type the pi symbol, okay? So that would be 15 times 4, that would be 60. And then I divide 60 by 8. And I want to write that back. Always write it as a fraction. I see 15/2 on my calculator, okay? And then I reattach the pi symbol. I am going to highlight that because this tells me that this wave starts at -pi/2 and it ends at 15pi/2, okay? So to get the period length, I'm supposed to take where it ends, which is 15pi/2, minus where it begins. I got a double negative here because I'm subtracting a -pi/2. I'm going to connect those two negatives, okay? So when on the calculator, you can combine 15/2 plus 1/2, okay? 15/2 plus 1/2, and that gives me 8. All right, so this is going to combine to be 8 pi. All right, so that is how many radians this wave takes for it to go through one cycle, 8 pi. The phase shift is where the wave begins, and that is that initial number, -pi/2, okay? The radians are a little bit more involved, mostly because you got to use your calculator when you're working with those fractions. Okay, let's try 1 in degrees. Let's take a look at number 6 here real quick. Okay, flipped over the midline, we're saying no. Vertical shift, that is where the midline is, that's -2. Amplitude is 3. Okay, now this problem is in degrees because I see the degree symbol there. So now I'm going to place 2x plus 90 between 0 and 360 degrees. Okay, I'm going to proceed with getting rid of the 90 from all three sections here. Okay, so I'm subtracting 90 from all three pieces. Okay, still have a 2x in the middle. Looks like that gives me a 270 over here, and then I'm going to divide all three pieces by 2. So this gives me officially, when I got the x in the middle, I'm just going to highlight this. This is what I have to work with. Okay, now remember, the period is found by taking where the wave ends minus where the wave begins. So again, I've got a double negative. I'm going to connect these. I got 135 plus 45. That gives me that this wave takes only 180 degrees to get through one complete cycle. And the phase shift is the number -45 degrees. Okay, now this one, I do have to graph this. Okay, so I want to use this inequality here to help me label my x-axis. I am no longer labeling my x-axis 0, 90, 180, 270, 360. I need to start over here on the negative side, -45 degrees, and then I'm going to mark over here 135 degrees as being like the end of this wave. That's the end, and this is where it begins. Okay, now to get the middle, you can just kind of mark off an eyeball like where the middle looks, but think about it. If you want the middle of these two numbers, then you need to average those two numbers together. Okay, so on the calculator, you would do something like this. You're going to average together those two numbers, which means you should add them up and you should divide by 2. Okay, so if you type in you'd want it in parentheses, but if you type in negative 45 plus 135, that's going to give you 45 degrees as being the middle of this cycle through the wave. Okay, now to get the 1/4 mark, I didn't do a very good job of spacing this out here. Now I want the average of these two numbers. So I need to, on the calculator, average together 45 and negative 45, which guess what that's going to be? 0. Okay, and to get the 3/4 mark, I'm going to average those two numbers. So I'm going to add 45 and 135 together, and that's going to give me 90 degrees. Okay, that's how you figure out how to get those 5 critical values. Past that, the rest of this should be pretty easy. You want to look at where you're saying your midline is. That's vertical shift. That's at -2. Okay, so I'm going to put that dotted midline there. You want to look at what wave are we graphing? This is the cosine wave. So I'm putting points directly on that dotted midline at the 1/4 mark and 3/4 mark. Now be careful, the 1/4 mark is now 0, and the 3/4 mark is 90 degrees. Okay, we said no, this is not going to get flipped. So that means at the beginning of the wave, if my pencil is kind of floating right here, remember beginning is at -45, my pencil's on the midline, I'm going to glance up here and say, what's my amplitude? My amplitude is 3. Well, that means I need to make sure that I can stretch up 3 units from the midline. Count 1, 2, 3. That's where I'm going to put that dot. In the middle, I need to have marked enough so that I can go down 3. Oops, that's negative. And remember, in the middle would be underneath the 45. And at the end, at 135, you're back stretched up again at 1. Okay, I'm going to get you started with number 8 because that's a radian problem. Might not get all the way through this, but we'll get started with this. Flipped, this one we're saying yes. Ooh, vertical shift. I'm going to say 0 there, okay? That means the midline is going to be right there on the x-axis because there's not a number being added or subtracted on the end. And the amplitude, notice I'm saying, is a 2, despite the fact that that was negative. Okay, I'm going to do this work over here off to the side. I can see a pi symbol here, so that tells me that I'm going to be working in radians. So I want to make sure I'm placing this between 0 and 2 pi there. Okay, I'm going to proceed by adding a pi over 4 to all 3 sections. I want my calculator to be pretty close and handy here, especially for this part right here. Okay, on the left I got pi over 4. In the middle I got 1/2 x, and here's where my calculator is going to come in. You're going to type in 2 plus 1/4. Okay, 2 plus 1/4. Okay, we're not averaging, you're not dividing by 2, okay, but 2 plus 1/4, we're going to type that in, and you're going to get 9/4, okay? Okay, the next thing, we're going to multiply by 2, all 3 sections, okay? And that's going to make this part here would be 2 pi over 4, which reduces to 1/2 pi, okay? X is by itself. This ends up being 18 pi over 4, which reduces to 9 pi over 2. Okay, this first number here, that's my phase shift. That's where my wave starts. That's the answer to the last blank. And then the period length is where the wave ends minus where the wave begins. That would be 8 pi over 2, which reduces to 4 pi. Okay, now here's what you want to look at. I'm going to highlight this here. This is what I need to use when I go to label the x-axis. Okay, I know the wave starts at pi over 2. I know it ends over here at 9 pi over 2. Now remember what we did with the previous example? To get the middle of the wave, we had to average the 2 endpoints. So I'm going to write this down below here, but this is what you're going to type in. You're going to add together just the coefficients. So just add on your calculator a 1/2 and a 9/2. But once you add those together, remember we're doing the average. So you want to add them together, then divide by 2. You're going to switch it back into a fraction always, and then you're going to reattach the pi symbol onto your answer. That's going to give you the middle 5 pi over 2. Okay, then repeat that process to get the 1/4 mark, which would be the average of these two. Okay, so you're going to then type in 1/2 plus 5/2, divide that by 2, switch that back into a fraction. That will give you, remember to always reattach the pi symbol on. Okay, and then the 3/4 mark would be the average of these two, which would then be 7 pi over 2. Okay, past that, I think we got our midline already in place here. This is a sine wave, so I should put points beginning, middle, end. My amplitude is 2, so I want to make sure I can mark to stretch up 2 and down 2. We are flipping on this one, so when I get to the 3/4 mark, which is right here at 3 pi over 2, I should stretch in the direction down instead of up. And when I get to the 3/4 mark, which is 7 pi over 2, I should stretch up instead of down. Okay, please reach out if you guys need help with this. This is not easy. I know it. Okay, let me know. I'm here to try to help you if you guys need more help.